But now let's not talk about too much about Epic. Let's talk about these 5 fantastic people we have here today talking about their fantastic products. So here is a bit the menu for today. So we will start with Ben coming from Luxinar, who will tell us a bit about this, one of their new, let's say, kind of sources for as ultra short pulse laser. We will hear from him already, but is matter really of controlling power and also pulses in burst mode to really access the best application that you wanna really address in your as a system integrator or also as end user. Then we have the expert of laser systems components, Teraxion. So Pascal is here today to present us a bit their new Med2 series. So is a special laser reflectors for high power application, especially 2 microns. So for medical fiber lasers, this is one application, and then we will hear from him also what are a bit the expectation towards the future products that Teraxion is thinking about. Then it's time for another laser manufacturer of Florian from Menir Photonics. He will be more on the side of the ultra low noise. So the lasers of Menir Photonics are famous to be ultra short pulses and for synchronization and for different applications. So I don't spoil already the surprise. Florian will explain a bit more what is that Menir 5050 is about to do and can do also for you. Then we move a bit towards the spectroscopy and imaging part, and will be time for Slava from our president of Earth Photonics. We present this probe, so really a new fiber that you can really use for different applications in spectroscopy. And we know broad range, but he will give us a lot of examples about how to use this new probe that is unique also for this multiple application you can use it with. And then last but not least, it will be time from Thierry from Silius Technologies. There, he will present today Toucan as really one of the snapshot multispectral cameras with the broadest spectral range. So he will show us that really they can address visible to near infrared in a unique way, in a unique broad range. So now, please, this is the introduction. Now I have to give the floor to the first speaker, because it's the best when Ben directly can share their screen and give the floor also to Luxinar. So Ben, thank you for being here. The floor is yours.
Okay. So thank you very much for the introduction. So I'm Ben Fulford, and I will be talking about the LXR femtosecond laser sources and power with control from Luxinar. So I'll start off giving a quick overview about who we are, and then moving on to the LXR series with an introduction to the series. We'll have a look at the power stability and beam quality. I'll have a look at the pulse on demand feature and the fast burst mode feature, and then finish off with a summary at the end. Okay, so Luxinar, who are we? Well, we are a laser manufacturer that's been around for well over 20 years now. So we're based in East Yorkshire in the UK, and we primarily make CO2 laser sources, but we are branching out into the femtosecond laser sources. So we have 6 sales and service centres worldwide, and the company is approximately about 180 employees now, I believe. Okay, so an introduction to the LXR series of femtosecond lasers. So the lasers use patented technology, so this allows us to give high output power with control. The lasers have a large dynamic range of pulse repetition frequencies and energies. Beam quality is very high, with M-squareds better than 1.3. We have a pulse on demand feature for high quality processing, a fast burst mode for increased efficiency with some of the processes. We also provide a PC app with each system, giving local or remote diagnostics of the system. There's a handheld touchscreen interface available. And for the infrared systems, we have 50 watts and 120 watts rated power systems available. And also the second and third harmonic variants available at 515 and 343 nanometers. So the table on the right hand side just gives a very basic overview of the LXR 120 1030. So 120 watts average power, pulse duration 900 femtoseconds. So individual pulse energies up to 120 microjoules, with a maximum fast burst energy of up to 600 microjoules. So the laser can actually be controlled from single shots all the way up to 40 megahertz, excellent power stability and beam quality. Output is linearly polarized with beam diameters around about 3 millimeters. So looking at the power stability of the system on the left-hand graph, you can see that this has been taken over a period of approximately 10 hours. Stability is excellent, standard deviation about 0.26% of the average power. The image on the top right, that is a typical focus of the beam, and the sort of caustic plot below it. So you can see from this that the power stability and beam quality of the systems is excellent. So the pulse on demand feature, so this is something that allows the laser to be controlled by an external source. So the external source can essentially tell the laser when to fire. So this is a useful feature if, for instance, using scanners where the mirrors are accelerating and decelerating. So you can see from the images below, without using this feature, you get a bit of a sort of a mess around the corner, whereas this feature, when it's enabled, you get a much cleaner process. So during this process, if the scanner is asking for a different frequency, for example, the pulse energy can be maintained whether 10 kilohertz is required or 10 megahertz. There's also a sync output, which enables the scanner to synchronize exactly with the laser output also. For the pulse on demand feature, we can actually operate this in a burst mode as well as gated. So the individual pulse energies can be set for each pulse within the burst. So the example here is a intraburst frequency of 10 megahertz, 50 pulses within each of those bursts, a burst frequency running at 100 kilohertz, and the whole thing being gated at a frequency of 10 kilohertz. So very flexible in terms of the control. So this example just shows how we've asked each individual pulse within the burst to have a specific energy. And this example here also shows a similar thing where we've actually requested each individual pulse with a specific energy, and you can also see it's actually operating at 9.96 megahertz, so very high frequency to be able to control that. So the fast burst mode for this is a key function for applications such as glass separation and drilling. So this can actually increase the efficiency of material removal whilst maintaining the high quality machining afforded by the femtosecond lasers. So this works off the base frequency of the oscillator. So this time the period between pulses is very short, around 25 nanoseconds. So we can now have the high energy pulses of 120 microjoules, but in bursts. So for instance, this burst here shows about 600 microjoules in total. So to summarize, the systems have a large dynamic range of pulse repetition frequencies and energies with excellent power stability and beam quality. Pulse on demand and fast burst mode are also available with a PC app with local or remote diagnostics. So we have infrared systems available at 50 watts and 120 watts rated power with the green and UV variants also available. So thank you very much for listening.
Thanks a lot, Ben. Thanks a lot for the introduction to the new product. So now we can come back to the room. Maybe you can stop sharing, Ben?
Yep, sure.
Yeah. And let me see. So, of course, every question is welcome for all of you from the YouTube also observer now that are watching at least those who are watching the streaming, of course. Otherwise, you will have to reach out to me if you have some questions, and we will give it further to our speakers. But now let's maybe talk a bit, Ben, about the other two wavelengths that you're offering, right? So all the data that you show were benchmarked on the 1 micron, right? Can you maybe give us a comment about how the stability is for the others? What are for example, also just the power and energy that I suppose is a bit lower, it's normal, but just to give us a kind of a bit of other data about it.
Yeah. So the green systems, we have an 80 watt version in green, and I think 35 watt version also. The UV versions, still working on those, but they probably be 40 watts and I believe 15 watts variants. In terms of beam quality, the actually remains excellent. Pulse duration probably drops slightly, so nearer towards the 800 femtoseconds. But those systems are also very, very stable as well.
Okay, very good. So now from your application that you reported, you were saying, okay, using scanner would help, and also a bit the glass processing systems. Do you have something else in mind, maybe for some specific wavelength? Because with 3 different wavelengths, of course, you don't do the same with all 3. Otherwise, you wouldn't offer it, right? Do you have some other maybe wish application, or where do you think that is the best way to go for you? Just an example. We don't want to tell you too many of your secrets.
Yeah, it's hard. It's a very difficult question because there's so many applications out there, and each application, depending on the material, favors a different wavelength. So it's difficult to answer. I suppose, for instance, glass separation, that does favor the infrared, for example.
Okay, but then it's more towards display application, or do you have something that goes in that direction, or more on smaller, like more microfluidics, this kind of glass? What is that you are thinking about?
It's more about sort of glass separations, such as cutting mobile phone screens.
Yeah, so like large and fast, right? Because we talked at the beginning about this and being high throughput. This is one of your plans. So of course you want to be fast or maybe on a flat surface. That is the idea behind it.
Exactly. The high average power is high throughput.
Very good, very good. Then one thing, just a bit more technical, the switching between the different modes, so also in burst mode, is all we saw in your slides that you had mostly this kind of software that is all. So is it all? I would say I expect is just for the end user, very easy, right? To change quick and.
Yeah, absolutely. So the system is shipped with a PC application, and all this can be controlled via a PC, laptop, or even a handheld touchscreen device. Similarly, on the rear of the laser, there's also some D-subs where the user can actually connect their own signals to if they wish. So it's very flexible in terms of its control.
Very good, very good. So if anyone here, so Ben is still here. So if you get some questions also from outside, please feel free to just maybe Tracy. Tracy, do you want to? Yeah, that's very related to the last question. So Tracy, please.
It is. So I was watching, I'm sorry, I came in a little bit late, but I saw your image from looking at a right angle turn, and that was quite impressive. So I was interested in more of how easy is this for a user to program, and also is it something that can be done on the fly, or do you set up the program and then it takes longer to program it for the next thing? How quickly can you switch between different modes?
So in terms of switching between different modes, it's as fast as you can click a button in the software. However, in terms of actually programming the cuts, what you want to do, it's very dependent upon the actual, I guess, the scanning software that you're using, the sort of partner equipment, if you like. Okay. So our laser is able to take these signals and do what the equipment is asking it to do.
This is great. That was really impressive, showing that right angle turn. That was great. So thank you.
Thanks a lot. Yeah, that is also one of the strengths, right? So any trigger signal can speak basically from your integrator and user speak with the laser, and then that is also pretty quick then switch of anything that is needed for the application. Yeah, thanks a lot, Ben. Thanks a lot for this.